उसमें क्या करते हैं, लाइक उसमें क्या किया था तुम लोगों ने?
सर ऑब्जेक्ट के 2D व्यूज बनाए थे, लाइक
ओके।
फ्रंट व्यू, साइड व्यू एंड टॉप व्यू, वो सब चीजें।
अच्छा।
और फिर शेप्स वगैरह बनाए थे, जस्ट लाइक हेक्सागन एंड ऑल दैट।
हम्म। तो कैड में और उसमें क्या लाइक डिफरेंस होता है, बता सकते हो?
कैड में और किसमें सर?
कैड में और तुम्हारी लाइक इंजीनियरिंग ग्राफिक्स में क्या, मतलब जो भी किया था तुमने, उसमें क्या क्या डिफरेंसेस हैं, बता सकते हो?
कैड में हम 3D ऑब्जेक्ट्स को इमेजिन करके उसके 2D व्यूज बनाना ट्राई करते हैं, लाइक सॉरी इसके अंदर इंजीनियरिंग ग्राफिक्स में। और शायद कैड में 3D व्यूज बनाने होते हैं ना।
हाँ, मतलब कैड में अभी तुमने जो किया है वो एक ऑलरेडी प्री एग्जिस्टिंग ऑब्जेक्ट है, जिसका डिजाइन पहले से दिया हुआ है, उसको बस तुम लाइक रिक्रिएट कर रहे हो।
यस सर, यस।
हाँ, अभी कैड में क्या होता है कि तुमको अपने आप से इमेजिन करके कुछ डिजाइन बनाना पड़ेगा, जो मतलब ऐसे रियल लाइफ सिचुएशन में हेल्पफुल हो सकता है, राइट?
यस सर। अच्छा सर, ये जो हम सॉलिड वर्क्स के ऊपर कर रहे हैं,
हम्म।
ये तो इसके अंदर हम कोड वगैरह भी करते हैं क्या? जैसे ब्लेंडर वगैरह पे शायद होता है कोडिंग वगैरह थोड़ा सा।
हाँ, ब्लेंडर पे होता है पर सॉलिड वर्क्स में नहीं होता है। सॉलिड वर्क्स में भी नहीं होता है, एंसिस में। एंसिस में लाइक नॉर्मली नहीं होता है, बट ऑप्शन है, करना अगर करना हो तो कर सकते हैं, पर सॉलिड वर्क्स में नहीं है।
तो सर व्हाई डू वी प्रिफर सॉलिड वर्क्स ना? ऑटोकैड 3D वगैरह प्रिफर क्यों नहीं करते हैं?
हाँ, तो ऑटोकैड 3D का यूजर इंटरफेस उतना लाइक, अगर मैं डिज़ाइनर हूँ तो मेरे लिए उतना फ्रेंडली नहीं है ऑटोकैड। बहुत लाइक मुश्किल से बनता है डिज़ाइंस, तो सॉलिड वर्क्स ज़्यादा इजी है। यस, एक ये ड्रॉबैक है कि सॉलिड वर्क्स लाइक स्टूडेंट्स को फ्रीली नहीं मिलता है, मतलब उसका क्रैक्ड वर्जन ही लेना पड़ता है। पर मतलब अगर वो ऐसा पेड सॉफ्टवेयर है तो उसका स्टैंडर्ड भी कुछ होगा ना, तो इसलिए तो वो फ्रीली नहीं दे रहे।
ओके सर।
हाँ। अच्छा, एक अच्छा लाइक इंटरेस्टिंग क्वेश्चन है। अ, कोई बता सकता है कि सॉलिड वर्क्स अगर खरीदना होगा तो कितना कॉस्ट होगा अप्रोक्सीमेटली?
सर डाउनलोड करते हुए चेक किया था, स्टूडेंट्स के लिए कुछ $60 था, एंड फॉर प्रोफेशनल्स आई गेस $100 के आसपास था।
$100 के आसपास?
या $90 to $100 समथिंग।
3 to 4 thousand।
ओके, 3 to 4 thousand अगर स्टूडेंट्स के लिए।
यहाँ पे 3750।
हाँ, सही है। और अगर लाइक ऐसा अपने आप के लिए खरीदना होगा तो लाइक नॉन स्टूडेंट लाइसेंस से?
सर महंगा हो जाएगा सर, ऑलमोस्ट
हाँ।
अब अब डबल, मतलब ऑलमोस्ट डबल हो जाएगा।
हाँ, डबल हो जाता है। और ये कारण ये है कि इसका यूज़र इंटरफेस इतना अच्छा से बनाया है इन्होंने, और इतना यूज़र फ्रेंडली है कि लाइक बहुत इजीली तुम डिज़ाइंस क्विकली बना सकते हो। और ऐसा लाइक जब मैं स्टार्ट करूँगा पढ़ाने, तो तुम्हें भी लाइक यू विल आल्सो नोटिस दैट बहुत स्ट्रीमलाइन है, कि जैसे तुम पहले स्केच बनाते हो और उसके बाद उसको 3D में कन्वर्ट करते हो, वो सब वो जो स्टेप्स हैं ना, वो बहुत यूज़र फ्रेंडली होते हैं और बहुत नेचुरली आते हैं, क्योंकि मैन्युफैक्चर भी इन अ सिमिलर वे होता है। ध्रुव, हाँ, स्टार्ट करें क्या? So is my screen visible to everyone?
Yes,
Yes,
sir.
sir.
Okay. So firstly, what
Yeah.
you do is go to new, and here you would see three options. One would be the part, one would be the assembly, and the third would be the drawing. So the part is basically a single component, like it is manufactured on a whole, and then it is then assembled using various techniques, and that is done in the assembly. The drawing is basically what you did in AutoCAD. It is just converting the 3D view to the 2D view. So once you have your parts ready, you can drag them into your drawing, and it would automatically like present to you isometric view, front plane view, top plane view, and your auxiliary plane, right? So to start now, so what I'll do right now is I'll basically talk to you and show you how the interface works and what the various tools are. And then we'll work on a part where we'll use these tools. And then if time permits, we'll try making an assembly, and we'll finish off with that. Okay. So starting off with parts, so I have opened up a part here. If you haven't, you can click on part and open up a new part. So firstly, this is the interface. On the top, you can see the menu bar. Below that, you have the taskbar with various tools. And here you can see that you have things such as features, sketch, surfaces, weldments, markup, evaluate, etc., etc. This Autodesk CFD and stuff is installed by me externally. So, like, if this doesn't show up on your system, don't worry. So yeah, here you can see that this represents the various planes and different views as you have learned in your engineering drawing. This is your top view, your front view, and your right view, left view, and so on. Right over here on this left side, you can see that you have your front plane, your top plane, and your right plane. You also have your origin, which is located at the center. This is the intersection point of all these three planes. You also have an option for your material, like you can, after you make your part, you can specify what particular material it is made of. If you have any annotations to make on the surface or on the component, you can use this. And there are various sensors that you can use, and this is your history, which shows you the previous parts you had made. So let's start off with the basic tools. Uh, so firstly, when you make any design, let's not talk about CAD, but let's give more focus to designing and the processes that are involved in designing. So when you're talking about designing, the first thing that you do is you draw it by hand, right? You draw it on a 2D plane, you imagine it in your head, and you draw it on a 2D plane. So firstly, we would do that. We'll select the sketch part, and then we'd open up a sketch. Here it would prompt you to select the plane on which you want to make your sketch. So you have the front plane, the top plane, and the right plane. So for now, I'll just click on the top plane, and now you can see that it's opened up my sketch. This is the top plane, and anything that I make over here would reflect on the top plane. So here are the basic tools. You have the line tool, which is similar to what you have in MS Paint and in AutoCAD. Uh, so using this, you can draw straight lines, and then you can also connect them, right? And when you make a closed polygon, make sure that if your polygon is closed, it should show a shaded region in the enclosed area. If this like shaded region isn't like visible, it means that at least one of your sides is open or there's some mistake in that. So yeah, you can also see that here your parameters show up. So this is the length of your line, this particular line, which is highlighted in light blue over here. This is the length of that. I can go ahead and edit that by typing 100, and you can see that that automatically reflects over here. Here are some relations. You'll see that if I select this particular line as well as this particular line and apply a relation that they are perpendicular, you can see that the angle between them becomes perpendicular. And this, you can see that this reflects in the existing relations. There are many other relations you can like mix and match between them and try them on your own. Next, we'll move to circle. Circle, as you know, is same as like what you have in Paint. The circle can be drawn using in two methods. Either you choose the center and then fix the radius, or else you can use the 3-point method where you select 3 points and then that forms the basis of your circle, right? So is everything okay up to here?
Yes, sir.
Yes, sir.
Yes, sir.
Uh, and in case you want to delete this, you can click over here and just slide, drag it, and you can select everyone and click on delete. Next, we have spline, right? So spline is basically a line tool, but it also allows you to bend the line a bit. And you all know that when you design your automobiles, you have to consider aerodynamics and then design it. And I mean, curved surfaces in general are more aerodynamically stable as compared to hard lines. So this is one application that I can think of where we use spline, and there are many other applications, just that I can't remember any other one right now. Right. So this is the spline. Once you fix this, you can then go ahead and change these to like whatever particular shape that you want. You can go ahead and change these. Right. After that, you have the rectangle. Rectangle can be drawn in so many ways, in 5 ways. The first, most simplest way is to select the opposite corners, and then that would draw your rectangle, right? Uh, and then you have your arc. While drawing your arc, you have your center and then 2 points, right? That is the most simple way you can draw an arc. Once you've drawn your arc, you can also go ahead to these parameters and then change the various parameters and then choose whichever particular one you want. Then you have the ellipse. So as you know, ellipse is basically slightly compressed on one side and elongated on the other side. So using this, you can set your longitudinal axis length and then your lateral axis length. Here you can add any text if required. Here you have a straight slot option. This looks somewhat like this. This is how the straight slot looks. And here you have some other curved slots that you can draw. Here you have the polygon option. You can select the number of uh, sides that you want and then choose a inscribed circle or a circumscribed circle and then draw the particular polygon that you want. Right. Uh, yeah. So after that, here's your sketch fillet. So let's say you're drawing a rectangle, and you can notice that the corners over here are hard lines, right? They intersect at 90 degrees. So if you don't want a sharp angle over here and you want rounded edges, you can go ahead to your fillet and then select your corners, right? So I've selected my corners, and then I can specify the radius required over here. Just a second. Yeah. Yeah. So like you can see that you have an option to enter your fillet radius. So if I go ahead and increase that, you would see the like radius of my fillet to increase or decrease as you enter it, right? Um, so this is how the like your figure looks after you do your fillet. This is a very good application because as you would have noticed, say you were designing a tabletop for a kitchen counter or something. Most houses, you would notice that these corners are not sharp so that they don't poke you, or say there's any small child in your house. So to prevent any misfortunate happenings, like they do fillet it, right? So another moving on to trim entities, you can see that as soon as I click on trim entities, it shows me the power trim option. So what the power trim option helps me do is that between any two given points, it helps me cut. Right? I just have to draw a line passing through that particular object, and it would uh, like remove it. Right? So you can see that I have 2 points and this is the line between it. And as soon as I drag my mouse through it, it removes it. Right? So that's what the power trim tool does. Uh, and then you can also offset entities, mirror entities, linear sketch pattern, move entities, and so on. I'll be talking about mirror entities and linear sketch pattern further. Okay, so in order to talk about that, uh, let's draw a small circle over here. So in your linear sketch pattern, you can see that uh, it makes a linear sketch, that is a reoccurring sketch in a linear direction, right? So you can see that this is my direction, that is my x-axis. This is the distance. If I go ahead and increase that distance, you can see that this would increase. Say I do 20 meter, sorry, 20 millimeter. This is how much my distance would be. And if I go ahead and increase this to say 10, I would obtain so many circles. Right. Now going to direction 2. So this is my y-axis, right? And if I go ahead and increase this, say 5, you can see that I obtain a matrix of this whole thing. Uh, if I go ahead and make this one instead of 10, you would see that this again becomes a linear pattern. And you can play around with this as per your application. You can play around with this and make the suitable choice. Moving on, like linear, yeah, tools. Mhm. Yeah, solar panel. Uh, you can also make a battery pack, right? Mm. It's in your made. Okay, so you can see here that when you click on the linear sketch pattern on the drop down option, you also have a circular sketch pattern. So what happens in your search circular sketch pattern is that you have something called your entities to pattern. So your entities to pattern is the uh, particular object that you want to, like, say, make a pattern with, and the other object is the circle that I want my pattern to be around, right? So I go ahead and I select my object that I want to be pattern, and this is my point. This is the point around which I want my pattern, and I can go ahead and increase the radius so that uh, my pattern forms around it, and yeah, that's about it, right? So that would result in the formation of a pattern in this manner. Okay. So say I've made all these entities. Now I want to move this particular rectangle over here, or to, like, say over here. This is want to move this rectangle, right? So I go ahead, click on move entities, and I select this particular one. And you have the parameter from to. So my start point is the center of this. Okay, let's say I move it from this corner, and then I move this, right? Okay, can anyone tell me why all my uh, rectangles moved? And can anyone also tell me what was the particular feature that you noticed when all these rectangles moved?
So can you please repeat this part?
This particular part.
Oh, yes, sir.
From where? Like from circular sketch pattern, is it?
So that how those rectangles moved away from the circle, that part.
Okay. Okay, so I click on move entities, right? And then I go ahead and select the particular object that I want to move. Uh, After that, you can see that in the parameter section, I have ticked the from and the to. So I then have to specify my start point. So say I specify this as my start point, and then as I move my cursor, this this is the distance by which I want to move this, right? So you can notice that all my rectangles start moving as soon as I move this. So can anyone tell me why this is happening? Okay. Oh, okay. Okay. Right. Previous. Okay. Uh, so in a way, this is right, but not completely right. So my objective was to move this particular rectangle only, right? This was the only one that I selected. So like ideally, what should have happened was that when I move this particular rectangle, only this should have moved, right? Why did the others move? So you must have noticed that. Let me redo that. You must have noticed that when I clicked on Move Entities and when I selected this, here there was an option to keep relations. So when we use the circular sketch pattern, there was an inbuilt relation that was built between the four rectangles that they would always lie at the same distance from this particular point over here, and that they would always be at a particular angle. That is why when I moved the rectangle uh, along the like theta direction as well, the other rectangles also moved accordingly. So say I do like uncheck this box and then I choose my start point. Can you see a difference? Can you unmute and tell me if you see a difference when I do that?
Yes, sir.
Right. So all of you
Yes, sir.
understood why it's happening, right?
Yes, sir.
Okay. Uh, Understand. Right. All right. Okay. So any doubts up to here? Like, can we move to features? Okay. Right. So okay. Let me do one thing. I'll make a linear sketch pattern of these circles and I'll just remove these rectangles. Uh, so you can see that I've got a matrix of circles, right? And like this does look uh, somewhat like when you have a top look of a lithium ion battery pack, would this be what you look at? Right. So let me go ahead. Like this is my sketch, okay? And I'll be exiting my sketch now, and I'll be moving to features, okay? So in the features, these are the various types of uh, features that you have. And for this particular example, I'll show you just a second. Okay. So I'll show you what happens when you use extruded base. Okay. So I'll go ahead and select all my circles. Hmm.
Sir, this is the isometric
Sir,
projection.
Earlier one was the top view.
the earlier was the front view and this is the top view.
Yeah. What's the exact? Uh, so like you notice that I selected on extruded boss base, right? So let me first tell you what extrude means, so that would help you understand what I'm doing here. So extrude basically means to push a plane from one point to another point in the same direction, right? That's what we're doing here. So when you extend a surface or a plane in a linear manner, it is known as extrusion. And this extruded boss base is what I mean. It's the same thing, and it helps us achieve the same thing. So let me do that again for you. I'll go ahead and select all. Just a second. Yeah. So I go ahead, click on my extruded base boss, and I select all these, right? Uh, so as you can see that as I'm selecting these circles, there's a predefined value of this uh, length that's specified that causes this extension, and it gives us a preview. This yellow thing that you can see here is the preview of how it would look if we did continue with the extruded boss base. So the one over here is the direction, that is this direction, and over here you can toggle with the length and stuff. See, let's keep it at 30, and like just like that, you can see that say 25 cells of my battery pack have been made, right? And you can also see that it's a very simple process. It didn't take me anything, like it was very effortless. I didn't have to measure each single one and then place them separately. So this is why this is the strength of SolidWorks, and this is why we chose, and many other companies in the international level choose SolidWorks over other softwares, right? Uh, does any uh, yeah. So this was the extruded boss base. I'll explain to you what the others do, but since we are working under time constraints, I'll leave it to you to explore those, right? So what does the boss base do? So the revolved boss base, say you have an axis and you have a particular 2D shape, right? That would be a planar shape. And you would be able to revolve this 2D shape about an axis, and this would result in the formation of a 3D shape. Say I had a circle and I was revolving this circle around an axis which is perpendicular to this circle, right? So what would happen is it would result in the formation of a donut kind of shape, right? Like unmute and just let me know if you got it, because I can't look at the chat right now.
Yes, sir. Yes, sir. A toroid.
Yeah, a toroid, right? So that would be repeat. Okay. So what I was saying is that I have, let's just say I have this circle, right? This circle, I have this circle, and I also have a, okay, let me take the top view. Right. So now I have various circles. Let's say I'm just selecting this particular circle, right? And I draw an axis passing perpendicular to it, like perpendicular to this direction, along the y direction or the x direction in this case, right? I draw an axis in this direction, and then this circle is located in the zx plane in this case. Now I want to rotate this circle in the y direction. So this I want to rotate this plane, circle such that it comes out of the plane and along this axis. So that would result in the formation of a toroid, or a like somewhat donut kind of shape. Right? Do you all agree?
Yes, sir. Yes, sir. Yes.
Yes, sir.
Okay. So moving on to swept Bossa base. So what happens in swept Bossa base is that similar to revolved Bossa base, you draw your cross section of your 3D object, and then you draw like a random direction along which this cross section is to pass, and then you drag it along that direction. So when you drag a 2D thing, 2D cross section into a linear direction or in anything, so you'll have a 3D object, right? That's what you have. In this particular icon also, you can notice that they have taken a circular cross section, and then they have swept it along a S type linear pattern, right? Is that right?
Yes, sir.
Okay. Next, we have the lofted Bossa base. The lofted Bossa base is also similar to this, similar to extruded base. What happens in the lofted Bossa base is that you draw two different cross sections. Say one cross section has a particular area, and the other cross section has a different cross sectional area as well as a different cross sectional shape, right? So you can say, like, say you're thinking of a frustum, like, right? The frustum of a cone. So you have two cross-sectional areas which are of different areas, and you draw like a there's a lofted boss base that occurs between them. So that's what the lofted boss base helps you do. The boundary boss base is what you use in many these cars and stuff. When you design the body of a car, this is what you use. You specify the boundary of the car, and then you use the boundary boss base to uh, draw this, like fill in the material between them, right? All okay until now?
Yes, sir.
सर बाउंड्री बॉस में समझ नहीं अच्छे से.
बाउंड्री बॉस में ठीक है. तो मतलब बाउंड्री बॉस में क्या होता है कि तुम्हारा जो लाइक कार होता है ना, तो कार को साइड से इमेजिन करो कि मतलब उसका शेप थोड़ा ऐसा एरोफॉइल टाइप शेप होगा ना तुम्हारा कार का. तो वो वाले शेप को तुम ऐसे एक्सटेंड कर रहे हो, वो वाला बाउंड्री स्पेसिफाई कर रहे हो, और उसके बाद जो मटेरियल है ना, उसको दो प्रोफाइल ऐसे तुम बना दोगे तो उनके बीच ये मटेरियल ऐड कर देगा। तो ऐसा करते हैं जब हम गाड़ी डिजाइन करते हैं, तब ये यूज करते हैं। इस इसको तुम एक बार एक्सप्लोर करना, अपने आप से समझ आएगा कि यहाँ पे देखोगे तो डायरेक्शंस होगा कि कौन सी डायरेक्शन में तुम्हें ये बनाना है, एंड फिर ये टैंजेंट फेस है या फिर रिजल्ट फेस है, ये सब तुम अपने आप से ट्राई करके करोगे तो लाइक समझ आ जाएगा। लाइक बेसिक तो इन मोस्ट केसेस एक्सट्रूडेड बॉस बेस, रिवॉल्व्ड बॉस बेस, एंड इन वेरी रेयर केसेस स्वेप्ट बॉस बेस यूज करते हैं हम। ये दोनों उतना यूज नहीं करते हैं, पर यू आर ऑलवेज फ्री टू एक्सप्लोर।
Okay, sir.
ओके, या श्योर।
Sir, we can't raise our hands here.
Yeah, definitely. Yeah. Uh, Not only doubts, like if you also have any idea, or if you can suggest any like different method by which you could have made that batteries, you can always suggest it. Or if you have any queries in that also, feel free to ask. Yeah. So what happens is like all these sites, there are certain sites that are blocked by the institute. So what you'll have to do is you can start off your download using your mobile data, and then as soon as your download begins, you switch to your LAN, and that would help continue with your download. Okay. The library Wi-Fi also doesn't work. Like it's the same thing as the LAN. So the certain websites and like other stuff is blocked on that. Right. Dhruv, can I start? Okay. All right. So moving on, like these were all the ways you could extend a 2D surface. Like the boss or base were methods that you use to add material, right? So now what do you use to remove material? So when you want to remove material, you use the extruded cut, the revolved cut, the swept cut, lofted cut, boundary cut, and so on. Okay. I'll be using this when I make the part, so I'll just skip past this part for now. Uh, Next, you also have the fillet, similar to how we had in the 2D. Right? We have the fillet. So let's try the fillet on one of our parts. Let me just figure out this thing. Right. So I'll go ahead and click on fillet, and then it would ask me for which particular item I want to fillet, and I'll go ahead and select the edge. All right. Make sure you select the edge when you're filleting. You don't make sure that you don't select the surface because that wouldn't be filleted there. And then I'll go ahead and decrease my radius, uh, or I'll increase it. And then I'll go ahead and click. So this is how it would look if I fillet it. Say this was a rectangular shape or some other shape, uh, like only one of the sides would have been filleted. Since this was circular, the whole thing got filleted. Right. Uh, Now you can also see that I have the linear pattern. Let's see what happens when I use the linear pattern. Let me select this. So I'll select the whole body. Right. So you can see that as soon as I selected this and when I specified the distances, it resulted in the same thing as what happened when I used the the linear pattern in the 2D case, right? But the benefit of this would be that instead of me having to select each individual 2D part and then applying the extruded boss base, what happens is that in this I would only have to draw one single cylinder, and then this would help me draw the 3D automatically. Right. So yeah, these are the various things that you can do in features. The other parts you can observe, like the draft is something that you can use to same like taper the particular surface, like the the surface area that is there, you can taper that using the draft, and using shell you can like you select only one particular surface and then you shell out the rest of the volume. And you also have various other parts. These aren't used that often, but yeah, you can explore it. And I mean, they're always handy. That is why they present such tools. Right. So let me move on to reference geometry. Okay. So reference geometry basically provides me with all these options. I'm about to go ahead and select on plane. Right. So as soon as I selected my plane, uh, it's asking me for my first reference. So in my first reference, what I have to do is I have to select a particular plane, which I want to keep as my reference. And then I want to select my offset distance. So if I increase this distance of the new plane from this reference plane would increase or decrease as required. And I can also use these relations so that if at all I change this particular value, this would change accordingly. So that's what happens in this case. And if I hit enter, you can see that a new plane one, has been created. Right. This is visible over here as well as over here. You can see that I have a new plane one. Okay. So let me just tell you briefly how I can use this new plane to create a totally separate sketch on this plane. Okay, so let me take the top view, right? So when I'm looking from the top view, if at all I make any changes over here, doesn't it look like my changes are going to reflect on the same plane that we made these circles on? Can anyone unmute the mic and answer?
Yes, sir.
Yeah. So it does look like if I do make some changes on this plane one, it's going to reflect in the same plane as we made the circle, right?
Yes, sir.
Okay. So I'll show you that that doesn't happen, and this is why we use this reference geometry and this plane. Okay. This might not be very helpful in this particular case, but in most other cases, it proves to be very handy. So I'm going to go ahead to sketch, right? Same procedure as what we did in the beginning. Go ahead to sketch, click on sketch. It will ask me to, since I already had my plane selected, it didn't ask me to select my plane, right? And now I can draw anything I want, right? So I just wanted to draw a circle, but now since I want to show you how convert entities work, so I'll go ahead and click on that. So as soon as I click on convert entities, just a second. Okay. So as you can see in this drop box that has come, it says that convert entities converts selected edges and sketch entities into identical entities by projecting them onto the sketch plane or a face, right? So that's what's happening. What's happening here is that I already have my sketch made on the top plane, and now I'm trying to import that sketch or project that same sketch with the same dimensions and stuff onto my new plane, which is identical to that to that plane. So I'm going to go ahead and click on convert entities, and then I'll click on my this circle that I've made, right? Okay, and then I'll go ahead and click on enter. So you can see that this arc has been made. Like when I only selected this particular arc, and you can see that now this particular arc has been drawn in onto my new plane, right? From the top view, it looked as if it was being drawn on the same top plane, but when you look at it from, say, an isometric view, or from another view, you can see that this new sketch, which has been made using convert entities, has been made onto a new plane, right? Any doubts in this?
No, sir.
Okay. So yeah, this was how convert entities works, right? So using reference geometry, I I drew my plane. I selected and drew my new plane, and then I went to sketch and I sketched on this new plane, right? And using convert entities, if we want to draw a similar or identical sketch from one plane to another, we want to say import the same shape so that we don't mess up with the measurements and stuff. So comes in very handy, right? Right. So let me exit this sketch and let me delete this particular sketch and also this particular extrude. Let me start off with a new sketch. Okay. Uh, Let me make it on the same top plane. So I'm making a square, sorry, a rectangle. Uh, I want to set the dimensions. So I go ahead to Smart Dimension, click on the line that I want to find out the dimension, and then I set this to 100. Click on this, set this to 200. Okay. So now you can see that I've made my rectangle 100 by 200. I now want to fillet my corners. So these are my corners. Uh, this particular fillet radius is very high, so I'll bring it down to 10. So now my filleted rectangle has been made. Now what I want to do is I want to extrude this, right? So I move to feature. Sorry, I exit the sketch. I move ahead to boss base, and I make a 30 millimeter. Somewhat, this looks somewhat like my mobile phone, right?
Yes, sir.
Right. Okay, so what I'm going to do now is I'm going to make a sketch on this top surface of this extruded object, right? So I'll select this plane and I'll say that this is the plane on which I want to make my sketch. So I'll go ahead, make a circle here. I'll make this 20 millimeter in radius. And now I want to bring this to the center of this, all right? So, I mean, there are many ways you can do this. I find one particular way very helpful, and that's using the smart dimensions, right? So I'll use the smart dimensions. I select on the circle center, and then I also do select. Sorry. Uh, I'll use the smart dimensions. Just a second. Yeah. So now I select on the smart dimension and I select this line and I select this particular. Okay. Okay. So I went ahead to smart dimension, and then I found out the distance between the center of this and the line, and I enter this as 100. Now I also find the distance between this point and this point over here, right? This point, the center, and this particular point, and this I want it to be 50. I want it exactly at my center. So after having done this, I move to features, extruded boss base, and yeah, I'll enter my distance, say 40 millimeter, and I'll draw my. So this now, like I taught you how we made a uh, normal extrusion, and then on top of that extrusion on a new plane, we made another sketch, and then we extruded that as well. Okay. Now I'll show you how we use the mirror tool. So to use the mirror tool, let me first make two circles. So here's one of my circles. Right. This is say 10 millimeter in radius. And now I want to draw another circle over here, which is at the same distance from the center and from the edges as this one, right? So now if I was to measure all these and then do it, it would become a very hectic task. So what I'm going to do is I'm just going to draw the center line of this, right? I'm going to draw the center line of this particular rectangle. This is just for reference. Now I'm going to click on mirror entities, and I want to click on the entity that I want to mirror. And then it also asks me for the mirror about, which is the axis about I want to mirror my object. So I do select that as well. And then as soon as I select that, you can see that it gives me a prompt and it shows me a preview of how my mirroring would look. So you can see that it's exactly the mirror image of what I had made. And I'll go ahead and click on enter so that my new image is, sorry, my new object is created. So there are two kinds of mirror entities. One mirror entities occurs in the 2D sketch, and the other one occurs in the features. So the difference is that when you're mirroring in a 2D sketch, the mirroring occurs with a straight line or some axis as reference. And when you're using mirror entities in a 3D, say, interface, you use a plane as your reference geometry, right? So now that my circles have been drawn, I'm going to go ahead to features, click on extruded cut, and select the objects that I want to extrude, right? So I've selected the two regions. Now instead of blind, I'm going to select on through all. So as soon as I click on through all, you can see that this is the it cuts through the whole material that had been added. If I clicked on blind, I could adjust the value through which it would cut, right? But I'm going to go ahead and click on through all, right? Because this is what I want for this particular application. And as you can see, when I clicked on through all, this region where I was prompted to enter my distance, that went away because that's already predetermined. So now when I do this, you can see that my hole has been made, right? Two holes, and they're exactly identical with respect to the center line. And yeah, so does anyone have any questions up to here? Anyone? Can you tell me using your mic?
No, sir.
So everything understood, is it? Uh, like, is there anything in particular that you want me to explain again, or everything is okay? Okay. One question. Can anyone tell me what I could have used? I mean, like, what would have been different if I used blank instead of like through all, and I did this? Like, what happened? Any guesses? Yeah. Anything? Like
Sir, same shape, just like a plastic body, transparent plastic body.
plastic body. Uh, and like, when would this happen? Like, what are you trying? When I use blank, this you're saying that it would look like a plastic body, is it?
By blank, you mean color, no? Like, nothing, like nothing.
No, no. Let me redo that once. No, I was asking that instead of using the through all, sorry, yeah, instead of using the through all, if I used blind, what would happen?
So maybe that portion would be hollow. It will be covered by both sides, but it will be hollow from the part that you had the distance in mind.
Right, right,
Yes, sir.
exactly. So what happens when I use blind is that I can set the offset distance. You can see that from this view. Let me just show you in a proper way. Right. So you can see that it's asking me for the distance by which I want to do my cut, right? That wasn't possible with through all. What happens in through all is that it means that the hole would extend through all the material that is present. But that's not the case when it comes to blind. Also, there's another interesting feature you can use. I can use the degree, like I can use the draft, and then I can set the degree by which this is to be made of. So draft outward, and then I can increase this, right? So what would happen in this case?
Frustum like structure will be formed like
Right, right, absolutely correct. So your this distance, yeah, this is exactly how it would look. Like you would have a different cross section on the bottom and a different cross section on the top. So this is what happens when I use, what is that? The draft. Okay. Okay, let's undo that. So this is my first part. Okay, I'll go ahead and I'll save that part one. I'll now open up a new part. Right. So I'll quickly go ahead to sketch, select the top plane. I'll make a cylinder. Does anyone remember what the dimensions of that cut was? Can anyone tell me? Okay. Uh, so I had used a 10 millimeter radius for that cut, and as you can see here, this is only a 0.5. Like it's saying that my radius is only 0.5, but still you can see that it looks almost as same as the circle that I had drawn previously, right? So why is this happening? So you can see that at the bottom over here, there is an option where you can edit your units. So this currently is being drawn in inches, pound, and second. And I had drawn the previous one in millimeter, gram, and second. Right. So this is what uh, made that difference, and this can prove to be very fatal because once you make one particular drawing in a particular set of dimensions, and then you try to make another part in another set of dimensions, then they may not be able to like you may not be able to make the assembly of those parts together. So be cautious about this. When as soon as you start your sketch, make sure that you are starting off with say millimeter, gram, second, or meter or inch as per your requirement, and then you make your sketch. So I'll go ahead to sketch, click on my top plane, select my circle, and yeah, make a 10 millimeter. That's my circle. I'll move ahead to features, extruded base boss, and I'll give it a height of 60 millimeter, right? So here's my cylinder. I'll use this cylinder to insert this in the holes we had created in that part, and yeah. So I'll save this part as well. I'll save this as part 2. I'll then open up an assembly. So, okay. So this is a new assembly, and here I already have my part 1 and part 2 opened up for me. I'll go ahead and insert them. Part 1, like I didn't select on part 2, so I'll have to import these into my insert these components into my assembly. So I'll go ahead, click on insert components, click on part 1, right? Part 1, and then I'll just place this over here. I also want another part 2 for me to insert in this cut. So go again to insert components, which is located in assembly, and then click on part 2, and then I'll place this as well. Okay. Yeah, I should have started with this first. So when I opened up my assembly page, it's slightly different from what was in the part page. In your assembly page, this is what you would have. You would have an option to edit your components, insert your components, mate your components, um, create a linear component pattern, smart fasteners, and then move component, and so on, right? And you also have layout, sketch, markup, and so on, which are similar to what we had in that. Um, so when we are creating an assembly using certain parts, can anyone tell me what are the methods that we use, or what do we try to do when we create an assembly, and how is it different from individual parts? Am I audible?
Yes, sir.
Right.
Yes, sir.
Can anyone tell me, like, what is the difference between a part and an assembly, and what do we try to achieve in an assembly?
So when all parts are combined, they constitute the assembly.
All parts to come together.
We try to arrange all the different parts in the assembly because uh, it will be better to actually make different parts individually and then assemble them rather than making them all in one place.
Okay, but like, what is your objective to, like, say I had to make, like, I had to put these two cylinders that I made separately into the same holes. I could have constructed that as a single part, right? Instead of creating a hole, I could have just extruded that, and then I would have ended up with the same thing that I wanted. You're missing a particular point that I want to hear.
So, because when we will, let's say, manufacture this thing, then there will be different parts, means we will be arranging them. So, maybe we are trying to actually show that in the drawing itself, means in this.
Yeah, yeah.
Uh,
So the parts may be arranged in different ways. So we require to visualize the parts alone. Then we can. Uh,
Even if I wanted to arrange them in different ways, I could have done that in the same part, right? Like, why am I uh, making that specific part separately and then using that in this? That the part can be changed. Okay, yeah, that can be an answer, but that's not exactly what I was. Okay, okay. Let's say you have a robot, right? You have a robot, you have a chassis, and then you have wheels, right? So the wheels are separate parts, and
And maybe because of moving parts we need to assemble.
yeah, exactly. So there are cases where you want certain parts to move, right? You want certain things to move, and that is why an assembly would be a better choice as compared to a part. Because when you have a part, it's a rigid body. Uh, it cannot move unless, like, you apply, say, an external force on it, and uh, because it's non-ideal, it does have some specific strain that occurs, so it does bend, right? So in order to like yeah, in order to avoid that, what we do is we use an assembly because we want movement, right? We want parts to move relative to each other, and that relative motion would help us achieve our overall target. Say, in case of a robot, let's say my chassis and my wheels are separate parts. So I want my chassis to move, and my wheels would help me achieve that. So me adding the wheels externally as separate parts onto the chassis would help me achieve that, and that would help me also achieve motion of the robot. So the same thing happens in this case. uh, I'll show you how you make a assembly using various parts. Just a second. Right. uh, okay, so now you can see that I have two cylinders which I want to insert in these holes, and yeah, and I also want these cylinders to be able to move, right? Once I do like fit them in, I would expect them to move. matlab, I would expect them to be able to move within this. So what I do is I go ahead to mates. So mate, what is mate? Can anyone tell me what mate is? Like, in the literal sense, what does mate uh, mean?
So two things meeting together, like means maybe touching something like that.
Yeah, you're right. Mate is basically uh, two surfaces or two interfaces coming into contact, right? And depending on the nature of that mate, that would define the way the two surfaces interact and the way they move relative to each other. So what I'll do is I'll go ahead and select the surfaces that I want to mate. I'll first go ahead and select. See, pay careful attention to the particular surface that I'm selecting. I'm not selecting the edge or this surface. I'm just selecting this extruded part. That is the surface area, right? So I went ahead and I selected that, and then I would also select this, and you can see that it automatically moves my part into this specific hole. Now I have the following options. I could have it tangential, I could have it concentric. In this case, the above three aren't applicable. I can only have this and this concentric to each other. I have an option to lock my rotation, which would mean that uh, the rotation would be locked, but it can move axially along this direction. And yeah, that's about it. So I'll go ahead and click on OK. So this is what I end up with. I'll show you a top view of how it looks. See, you can see that it's fit in perfectly into that cut that we had made. And yeah, now we can see that I can move this axially as well. Just a second. Yeah, okay. One mistake that I made over here is that uh, I clicked the whole body. So what happened is that they aren't intersecting right now. So we go ahead and do this. So I think this would allow me. Right. Right. So what happened was that this was my fixed body and this was my free body. So now I'm free to move this anywhere along this, and you can see that this movement is only restricted to move along the axis of this cylinder. See, outside of that axis, it's not allowed to move anywhere. So this is what my mate has helped me achieve. Right now, I'll try to achieve this with this specific cylinder as well. I'll go to mate. I'll select my cross-sectional area. Till then, select the inner cross-sectional area. And then I'll select on the same thing. Right. So that again helps me achieve the same thing. Now you can see that since these two are independent of each other, this helps me also achieve some kind of rotation, right? And you'll also notice that as I move the cylinder, it would always make sure that this is maintained. And if I were to rotate this, it is still maintained on this side, right? So this is how a basic a basic mate looks like. There are many advanced mates that are present. There's a mechanical mate where you have a cam and a follower, where you can have a slot, a hinge, a gear, and how they would interact. So if I had a gear, say I would create a mesh between the teeth surfaces, so that proper gear meshing would occur, and as I move one gear, the other gear would also correspondingly rotate. So this is what uh, yeah, this is overall idea of how we use mesh and how we use mate and how we use assembly. And using this, you can see that this is the reason why we have used an assembly and not a single part where I added these two cylinders into these holes, right? Because I want to achieve some kind of movement using these. That was the whole objective. Okay. Uh, yeah. One more thing. I'll just move to parts and I'll show you. Uh, yeah. Yeah. So I have my cylinder right here. So can anyone tell me particular material that I should make the cylinder out of?
So iron or aluminium.
Iron is it? Yeah. So in order to select the material of my part, you can see this option over here, right? And it says that I'm yet to specify the material that I'm using. So I'll go ahead, click on that, edit material, and then it gives me a whole database of materials that are available. What was the material that you told me? Iron, is it?
Yes, sir.
So here I have iron, ductile iron, and its variations: gray cast iron, malleable cast iron. So I'll go ahead and click on gray cast iron. It will show me the properties of this component of this material, and also material selection is a very important uh, what do you say step when it comes to design. It affects the overall performance of your design, because if your design is made of, say, a very uh, flexible material, you won't be able to achieve the strength that is required. Right. So I'll go ahead and apply this. So I have applied this, and you can also see that it's changed my color. So since gray cast iron has a dark charcoal black color, you can see that the cylinder that I've made is also of that color and that material. So now you can see that when I click on evaluate, I'll go to evaluate, I'll click on mass properties, and now since I have specified the material, it will show me different metrics. It will show me the density. So the density of cast iron is 0.01 gram per cubic millimeter, mass of 135.72 grams, and volume of 18849.56 cubic millimeter. This is my surface area, this is my center of mass, and there are various other parameters. You must have seen most of these in your engineering mechanics, right? This is your principal moment, and this is your moment products. So you can see all of these, right? And this would basically help you evaluate the performance of your part. Is it strong enough to withstand the external things that are acting on it? And all these things you will be able to evaluate using this evaluation and in specific mass properties, right? Did everyone get this part? Is there any doubt in this part, or does anyone else have any other choice of material? Huh. Yeah, just right. Of the yeah, you can change the color as well. Right. Thanks for bringing that. Uh, like you can change the color of the material as well. You can see that there is a ball over here which is in four different colors. You can see that as soon as you pass your cursor over it, it says that appearance, scenes, and decals, right? So when you go to appearances, you can set the color and the texture. So in order to select my color, let's say this is what I want. I'll I'll go edit my color. Okay. This is the edit option. So, yeah, I, yeah, I think my library has been deleted, so I don't know. Mm, I think that's it. Does anyone have like any question on anything specific? Like, yeah, anything, any questions or like anything in specific that you want me to explain to you, other than what was taught to you?
So I have one doubt that how did you make one of those parts means static and the others are moving? Didn't get that part properly.
Yeah. So actually, what happens is that the first, usually when you're like when I was supposed to insert components, right? Uh, I selected on this particular, sorry, this particular uh, cylinder. So what happened is that since that was the first part that I inserted, that particular part became fixed. So that was considered as my reference. So in general, like I forgot to do that. What happens is that when you're inserting your components, the first component that you insert is the component that you want as your base. So ideally, what I should have done was that I should have inserted this particular like part one as my first component, and then I should have added these two. So then this would have been fixed, and these would be able to move. Since I inserted this particular part first, this became fixed and the others uh, became like free to move. I can also change this, but I'll have to like I'll take some time to check and tell you how to change this.
Okay, sir.
Ah, rough and in the sense that on the same part you want to show them separately. Is that what you're trying to? Okay. Yeah, so probably different phases. I'll do that. Like I think that should be possible. Uh, grouping. Hmm. So here's my color. I'll just show you how I change the color, or I can also show you. Yeah, here you can see that this particular face has a different texture, and the one on the top has a different texture. Right? So it is possible for you to have two different, like say one have one rough and one smooth or something like that. I don't have those libraries. I think I deleted. Yeah, yeah. Actually, I think I have it. Okay, rough. Yeah, it's just I think it's represented in this manner. So this is how my rough is represented. Yeah, you'll have to do. Hmm, right. Yeah, I can search. Yeah.
Sir, as we have given it properties of metal, so it must have had weight. So can we calculate the moment of inertia using just SolidWorks? Like, does it have any feature like that?
Yeah, yeah. So when I went to mass properties, you can see that here you can see the moment of inertia. It's showing you the values, right? These are the principal values, and here below you can see the other values.
Okay,
These
sir.
are the
Thank you, sir.
moment. Yeah.
And can we specify axis about which we need a moment of inertia? Like,
Mm,
there are three given axes, but if we have to specify it,
yeah, you can. I think uh, this is taken at the center of mass, uh, and this is at the coordinate system over here. You
okay.
can also recalculate, I think, and you can select on options and then use custom settings. Okay, not in this section. Override mask.
Oh, okay, sir.
Yeah, here I think you can select your axis, right?
Yes, sir.
Okay, okay.
It's the open CV. Open CV, sir.
Good night, sir. Bye, sir.
Bye.
Bye.
Bye, sir.